welcome back to another Chem 2302 lab experiment primer video. Pipes carrying water can be made up of different materials, with one notably being copper. Leaching of copper can occur, contaminating drinking water. Today, we'll provide you with a method for quantifying this trace metal in water using graphite furnace atomic absorption spectroscopy, or GFAS. Although minimal sample preparation is needed here, a lot can still be learned from this experiment. Key takeaways will be how to use GFAS, create calibration curves, and quantify copper in your unknown samples. With less sample prep comes less tips for experiment 4. Let's get started. While creating all your copper solutions, 0.2% nitric acid will be used as your diluent. Why is that? Nitric acid prevents sample leaking from the graphite tube and results in a sample drying evenly. With that in mind, don't forget to use it in all of your samples. In this experiment, lots of solutions are made and dilutions performed. You'll need to make sure you're efficient with your time to make everything, keeping in mind that the GFAS instrument will take about 60 to 90 minutes to process your samples. To mitigate delays, reach out to your TA or lab coordinator to confirm your pre-lab calculations are correct. Wow, this was a quick one. Once you've acquired your GFAS data, a calibration curve will be used to determine how much copper was in your unknown samples with precision in your post-lab report. Carefully read through experiment 4 in your lab manual to be familiar with all experimental steps. Good luck, and stay curious.